So I think we're live. Hello, hello. Welcome. Good day. So hello world, hello stream. Welcome, welcome. I wanted to get a little bit of time in here on stream. Just because I wanted to stream. I had kind of a later day at work, and then did get home almost 2.5 hours ago. But I don't know. Had food, chatted with my parents, my dad rather. Watched some stuff online. Very oh man. It's time for bed already. I wanted to just do something here on stream before I go to bed. Just get some time in. If alarm's gonna go off soon, I'll set it for 30 minutes from now. Yeah, man, I don't know what to think. Just a moment. Well, I'll just kind of stick to the plan for the time being. Continue to stay the course. Finish what I was working on here, and then after that, I don't know. I'll figure out what to do. It's kind of important for me to have something, a plan, because time seems to move so quickly. But if I don't have some kind of a plan, I could be in deep doo-doo very quickly. You know, fall behind too fast, too quick. It's not that I'll really fall behind. I mean, it just, time moves quickly, and if I'm wasting it, it's like you don't get that back, and that's not good. That is not good. Yeah, stressful to think about. So anyway, we have. I said I was going to come back to the other problem. I think it's 152. We're almost done. We're very close. Latin squares. Yeah. So I sorted this one out. Just quickly go over it again. Latin square of order n is n by n array that contains n different elements, each occurring exactly once in each row and exactly once in each column. For example, among the following arrays, only the first one forms a Latin square. That would be this one, right? ABC, BCA, CAB, and then ABC, BCA, CAB. This one is not a Latin square because it's got CAC, and this one also is not a Latin square because it's got a D thrown in there. And what they're suggesting is consider a series of vectors. I'm going to just skip over here, but consider a series of vectors. And what you're going to do is you're going to take the longest length vector and all the vectors that have the same length, so maximal length vectors, leave them in their respective positions, and then you're going to create what are called quote-unquote alignments by shifting the smaller vectors from left to right, and each alignment will be another shift. So you end up with the 9 alignments given these vectors, because you can move them. This one you can move into 3 positions, right? 0, index 0, starting at index 0, starting at index 1, starting at index 2. That's 3. And then you can similarly, for each of those possibilities, you can also have another 3 possibilities. Index 0, index 1, and index 3. Right? And then obviously there's a Cartesian product of these possibilities. So you get a whole bunch of different alignments are possible. Call them quote-unquote alignments. And what this question is looking for is, given a particular alignment, figure out how many Latin squares exist. Find all the Latin squares that exist within that particular alignment. So here you have 1, 2, 3, 2, 3, 1, 3, 1, 2, 1, 2, 3, 2, 3, 1, 3, 1, 2. So here's one Latin square in this alignment. And for each alignment, collect all the Latin squares, and you're actually going to count them. That's what they want here. They want to say every unique Latin square that exists in all of these alignments, group them up by their length, their size, which is just one of the sides, length of the side to the square, and based on the length, count how many unique such squares you see. So like if you say a square of length 3, there's 1 here, and then there are squares of length 2 in this one. There's 1 unique square of length 2 and 1 unique square of length 3. So the unique square of length 2, I think, is this one, right? 2 1 1 2 2 1 1 2. So this is one of them, and this is the other. And they note also that there are actually 3 other cases where you see this particular square. Let's see if we could find it. I got one here. We have one here. It's 2, 3. Yeah, 1 2 3. So we have 3 squares across here, and then 1 square here. But these obviously are all the same square, right? 2 1 1 2. Here you go. It's all the same. So now you have right. So that's what they're asking for. It's relatively straightforward. Once explained, it's kind of a lot of words to explain it, but once you get it, it's not too bad. And I solved this already. Let me just run this. Although this is another one of these, almost over 100 lines of code. The approach is pretty simple. You kind of got a hint of what I ended up doing to solve it. And I basically said, yeah, all right, we're going to take these alignments and create these Cartesian products and generate all these possibilities. And then within those possibilities, we're going to generate all the Latin squares that are possible. And then, all of the squares that are possible, right? And then obviously we're gonna check each of those squares if they are Latin or not. And we're also going to discard. We're going to use I call it a disclude character. So for the spaces here, we're actually going to throw that character in there and say if we check that it's Latin and we see that character, then we're going to discount it as a possibility altogether. You could have filtered it differently and said like throw in this extra character, and then when you're generating the squares, throw out those squares, and kind of kept the Latin question separate. There's sort of a lot of improvements you could make and could have made, but that was the basic idea. It was like really simple overall, the idea, and I did it in a not so simple way, sort of. But obviously, if I think about it more, work on it more, I could come up with a better approach. But I'm trying to kind of get through these as quickly as possible. But yeah, that was it. That's all I did. Is I said, all right, we're going to create the lengths we're going to get. So we're going to create a range from 0 to the difference between the maximum and the maximal and the vector you're looking at. Arrange over all those indices. So here you'd have just 0, and then here you have 0 1 2 0 1 2. Create the Cartesian product of those things, those positions, and then you can generate the rectangles based off of each of those Cartesian products, right? And then each of those rectangles you can then perform another routine to get all the squares for a given n, certain size square. To create a Cartesian product, and then finally, or rather not Cartesian product, a square, right? Generate all those possible squares, which actually was pretty concise on my end. I was actually kind of proud of that. This is a one-liner that partitions appropriately. It gives you all the squares for a particular rectangle, and then there's a simple routine to check for the Latinicity, we'll call it, of your rectangle, which is this one. This one I probably could have made a little more concise also, but yeah, it's simply put, you have an excluding character if you see your excluding character. Oh yeah, I also used frequency maps to measure, which is kind of interesting, instead of using a set. And the reason I used frequency maps is that you can actually you get kind of weird solutions with sets on cases like this, because you have multiple values in the same row, and it gets a little confusing. And so I had a little more extra logic in there, some logic about a disclude character and some logic about whether or not your frequency map has only one value of each in the map. Yeah, nothing too complicated here. I mean, I just coded that out, what I just described. Yeah. This extra character though doesn't handle all possible cases though. This exclusion character because you technically could put whatever alphabet you want in your Latin square. There's no way of knowing in general if that exclusion character is some character. What you could do is parse the entire structure, I guess, entire data structure for all of the things that are in there, and then I guess try to get something that's orthogonal to all of them, something that's not in any of them, as your quote-unquote exclusion character. I'm not really sure entirely how you would do that though, because these could be anything. These could be strings, they could be numbers, they could be symbols. You could maybe create a new symbol out of these things. I don't know. I mean, I really don't know. I guess you just have to. I guess you kind of have to know before you process the thing what you could use as an exclusion character. There's probably a way to formulate this that doesn't involve a quote-unquote exclusion character, which basically would like kind of maneuver around these cases. Excuse me. Not really entirely sure how you might do that. Like, in other words, when you're generating the squares in the first place, instead of negating those ones, you could like know which squares would contain those values in the first place and then exclude them. So maybe you would say something like maybe you would have a set of positions that you would generate for each alignment, and then you would say then I guess knowing what n is and knowing what your starting point is, that square, you can determine whether or not that square would contain one of these elements in it. Something like that. Like, I really don't know. I mean, I couldn't think of a simple way to exclude those squares that have this sort of extra value in there from the rectangle. You could alternatively consider. No, it doesn't work like that either. I was going to say maybe you could just box off the rectangles that you could process, but that doesn't work because there's multiples of those, right? Like, here's a square, here's a rectangle, here's another rectangle. Both of these rectangles could contain Latin subsquares. That doesn't really work either. Now, I think the simplest way is to just get rid of the ones that have this extra, quote-unquote, extra spaces in there, but it's kind of hard, I guess. I don't know. I couldn't think of something better. Could not think of something better. It was also kind of quick to put together. Could maybe could maybe. Yeah, I guess you could do when you're generating the squares, you could say generate certain squares from a certain starting point, and then only generate, like, moving downwards, only generate as far as you can go downwards and as far to the right as you can go, and then also don't generate things at these missing points. Yeah. You have the vector size, so you can figure out how far to the right you gotta go. Don't necessarily know. Excuse me, don't necessarily know how far do you need to go down. Although that doesn't really matter that much. If you're going to be generating the squares, counting down the side is just, it adds a little bit of extra computation, but not much more. It's still asymptotically the same amount of computation. So yeah, you can just count down the side to figure out the maximum, and then yeah, you want to take the minimum of the left to right maximum and the top to bottom maximum. You actually want, no, I'm sorry, you want to take both of those as a rectangle, and you want to use those to get all of the possible squares. Yeah, I guess that works. I guess that's fine. And I guess you do go top down. Yeah, you go top down. If you're going to go from every position, you just go from that position downwards, down and to the right, to get these rectangles. Yeah, you could do it that way. That would work. A little less efficient, a little more programming stuff going on, but you could do it that way too. And that way you don't have to use any kind of quote-unquote exclusion character or discluding character. But I mean, it's just easier to do it this way. These are super simple test cases, so super simple cases, use cases. So it's, I think that happens in practice pretty frequently, where you say to yourself, look, this thing that we're working on, it's going to work a certain way, and then after 50 years or 100 years, it's not going to work properly anymore. But it's like, company might not even be around in 50 years. Who knows? So it's definitely something to think about. Yeah. Coding for the moment. It's like, yeah, sometimes things, they just don't last that long. Anyway, so yeah, all right, that's probably enough for this solution here. Let's go to the next one, 152. We should go to 153. I think we showed this one on stream. This is pretty simple. So, given a set of sets, create a function which returns true if no two of those sets have any elements in common, and false otherwise. Some of the test cases are a bit tricky, and so pay a little more attention to them. Such sets are usually called pairwise disjoint or mutually disjoint. So this is kind of a simple thing. This notion of pairwise disjoint means that if you're given indices I and j, or yeah, we'll call them, if you took a set and you indexed that set, and you took indices I and j such that I and j are not equal to each other, really should be a set of sets. So you indexed your sets within that set, and then you considered, right, indices I and j such that I is not equal to j. So you're never looking at the same set twice, sort of thing, right? If I and j are equal, that means it's the same set. So you're looking at a set compared to all the other sets, and you're doing a sort of, it's called round robin, is another expression for that. Pairwise disjoint means that for every one of those pairs, the intersection of those two sets is empty. There's no common element between any two sets. That's what it means to be pairwise disjoint. Pairwise disjoint. It's a pretty interesting question. Not the same thing as the entire intersection of sets being empty. Because the entire intersection, it actually implies that the entire set of the intersection of all the sets is empty. But the backwards implication is not true. You could actually have something that's common between two sets, but is not common to is not common to at least one of the other sets. So that's another sort of important thing, that pairwise disjoint is a stronger notion of exclusion than the entire set intersection being empty. Because pairwise disjoint implies that and then some. Partitions, by the way, are pairwise disjoint by definition, which is very interesting. So, and actually equivalence relations and partitions are sort of required, that's sort of a common concept, pairwise disjoint. So it's a very important concept, pairwise disjoint. Modular arithmetic is pairwise disjoint between the equivalence classes, right? The things that are 0 modulo 4 and the things that are 1 modulo 4, 2 modulo 3, 3 modulo 4, each of those sets are pairwise disjoint from each other. So this is it's interesting notion, common notion, important notion, and we solved it already. And the way we did it is we used just a simple Cartesian product, just loop over all the sets, process all these sets. So you just have a for construct. I think they call it a for comprehension. S1 is this set of sets, and then S2 is going to be the set of sets disjoined from whatever set you picked here. So you just take all the other sets, not including the one you just looked at, and you're going to have some duplicate calculations here. Basically, when there's I and J, and then there's J and I, right? When these two flip positions, it's the same. The intersection obviously is not associative. A commutative. So it's the same calculation, but it doesn't really matter. It's not really giving us much more efficiency if we skip those, and it doesn't affect because it's just recalculating the same thing twice. It doesn't make a difference. This is sort of an idempotent quality anyway, that if any of these return true, if any of these sets are non-empty, then you return false. So they all need to be empty. So the same thing, two things being calculated as empty twice or not empty twice doesn't make a difference. And that's it. Yeah, real simple. Just is every one of these empty for all of these? Choose one of the set and then compare it against all of the other elements of the set using just a simple intersection. There you go. Super simple. So 154 we're going to go to now, which doesn't exist. I think at this point I got kind of this is also a super simple thing. So what's being asked here says retrieving values from a map. You can specify default values in case the key is not found. Right, when you retrieve you can do that. However, what if you want the map itself to contain the default values? Write a function which takes the default value in a sequence of keys and constructs a map. So this is actually kind of silly, this question, because they're basically asking you to just take all the keys and give them a value, all the possible keys, which it doesn't really make a lot of sense. It actually should be anything that's not a key in the map should give you, it's actually a little bit harder to do this, I guess, the way that you would expect, the intuitive way, which is if the key you're looking for doesn't exist in the map, i.e. there's no value associated with that key, then always return something specific. Given any map, creating such a map is actually kind of difficult to do, because the way you would do it otherwise is you would just alter the get command to say, oh, you can default to this other value if you don't find the key. But to make any get command automatically have any kind of access or automatically have a specific default is, I think, almost might be impossible. I don't know how to do it. It's definitely really difficult. I don't really know. I think you'd have to use a different map data structure entirely that has a default value specified. I don't know how that works. But anyway. But yeah, what they're asking for here is a lot easier. They're saying just create a map where all of these keys are associated with the same value, this specific value. And so I said, all right, you just zip map with these keys and this thing repeated. Thought that was simple. Some the other folks had interesting solutions too. Oh yeah, zip map, interleave, repeat, associate. There's a bunch of different ways to do this. I thought zip map was the simplest. Zip map just takes keys, values, sequence of keys, sequence of values, and it'll create a map from the keys in sequence from this key to this value, right? First of the key, the first of the sequence, second of the key, second of the sequence, etc. And also they gave the value in the keys backwards, and all I had to do is just repeat the values. This is just a sequence of the same thing repeated indefinitely, lazily and indefinitely. So yeah, it's a pretty simple one too. Let's see, 157. Okay, indexing sequences. Simple thing here too. Transform a sequence into a sequence of pairs containing the original elements along with their index. So original elements along with their index. So we just want to get the index. Yeah, there's actually a function that does this explicitly. It's like something like mapped index or what have you. I decided to interleave with a range and then partition. But you can interleave with a range and partition, or you could what else could you do? You could there's another way that was kind of neat. I liked the partition though. It was kind of simple. Instead of partitioning and interleaving, you could have used map vector. That works too. Over this and the range. Mapping vector I liked as well. I thought that was pretty good. And then finally you can, there's a thing called like map indexed or something like that, which you'll see in the solutions, which is actually intended for this. Yeah, map indexed this. Although I don't really like using map indexed personally. It actually wasn't the most clean thing, but it's actually intended for something along these lines. Map indexed. Why, what does that do? The result of applying F to 0 in the first item of the collection, F to 1 in the second item. Oh, okay. Yeah, so map indexed is, it basically will just give you, it actually is kind of meaningless because you could just throw in a range value in the front, a range collection, and you'll end up in your regular map and you get this like the same thing. Not that it's meaningless, but it's a little bit less, it's a little less interesting than I thought. Okay, I see why they had to use vector. But yeah, this is the one I was saying. I think it's a little more clever. Yeah, either list or vector is required because this is actually uses a function. And also you notice that they didn't make this thing like a function. They just plopped it right in there. It's just sort of macroed right in. Okay. So I think it was 157, right? 57, 158, decurrying. I think we went over this too. There's a very concise solution, right? We did this yesterday. You can just reduce. This is all this is asking for is if you've got a curried function, which is a function of a function of a function, right? Sort of each time specifying the variable of another variable, that function. Finally, at the bottom, a function that requires all those variables to compute. You can decurry, quote unquote, decurry that function and return a function that takes all four of these parameters, and returns the result of sort of applying each of these parameters in sequence. And should be no surprise that this is as simple as just taking this, returning a given this function, you return a function that takes a sequence of arguments or a series of arguments, and then reduces over each time. Each of those arguments starts starting with the function you were given. Calls the function on the next argument, which then returns another function, which you then call the next argument on that next function, and you just loop through all of your arguments of functions in that way. And there you go. You end up with a super simple solution here. And I think all the solutions look similar to that. Yeah. My original solution was way more involved. Did not use a simple reduce. So that was 158. It did the same thing, but it did it in a much more roundabout way. 160, 161, subset and superset. I think we looked at this already as well. This is trivial. This is just the concept of supersets and subsets. So 321 is a superset of 2. 321 is a 1 is a subset of 321. 321 is a subset of 12, and 12 is a subset of 321. Let's go to the next portion here, which is 162. And it's time for bed. This trivial as well. They're just showing about logical falseness and logical truth. So anything in Clojure that's nil or false is false. Everything else will test true. So they're showing like even an empty, what do they call that? Even an empty, what's the name for that thing? Even an empty vector will return true. Vector containing 0 returns true. 0 itself is considered true, and 1 is considered true. All right, all of these give you 1. True is true. Not nil gives you true. Not false gives you true, and then all these other things are just true by default. 163. 64. And this is where I stopped. So this is tomorrow. I'll come by and show you what this is. So this is a deterministic finite automaton. Is an abstract machine that recognizes a regular language. Usually a DFA is defined by a 5-tuple, but instead we'll use a map with 5 keys. So set of states for the DFA. Alphabet is the set of symbols included in the language recognized by the DFA. Start is the start state of the DFA. Accepts the set of accept states in the DFA. Transitions is the transition function for the DFA, mapping states by alphabet onto states. Write a function that takes an input as input a DFA's definition as described above and returns a sequence enumerating all strings in the language recognized by the DFA. Note, although the DFA itself is finite and only recognizes finite length strings, it can still recognize an infinite set of finite length strings, and because stack space is finite, make sure you don't get stuck in an infinite loop. It's not producing results every so often. Yeah, this is really interesting. So basically, DFAs are equivalent to like regular languages, or alternatively, you could think of regular expressions. Although modern regular expressions are a little bit different than actual regular languages, but they're very close. They're closely related, and basically what this is asking is, given a DFA, figure out which language the set of strings of this DFA will match. And basically the idea with the DFA is you have like a bunch of states. There's a whole wiki on it, but I'll just quickly, DFA wiki. You're given a whole bunch of states and transitions. You're given a bunch of states with transitions, and so you would say, okay, you know, if you're in some starting point, so maybe you start here at S0, and if you're given like 0, 1, 1, 1, 0, right? So you start here. This is the acceptance state as well. So wherever you start at, whatever you start with will be accepted. So I guess the empty string is accepted, and then 1, 1 is accepted, and then 1, 0, 0, 1 is accepted, and then 0 is accepted, and 0, 0, 0, 0. Any number of zeros is accepted, and then 1, 1, any number of zeros is accepted, etc. So there's a whole bunch of different strings that are accepted here. And this question is asking us to basically enumerate lazily the entire sequence of what's accepted given some DFA. And the DFAs are described with 5 pieces: the start state, or the set of states, the alphabet, right, 0, 1, the start initial states, the accepting states, and then also the transitions from state to state, what you could possibly transition with. So obviously here, every state seems to have, well, there's really, right, there's 2 different transitions for this state, right? 0 goes somewhere, 1 goes somewhere. 0 brings it back to itself, 1 brings it to the next state here. So that's, also I need to go to bed, and I think my voice might be a little too loud. Forgot about that. Yeah, and that's a DFA in real simple terms, and what they're asking for. So the way to do this, in my opinion, is to do it lazily and to do it without causing infinite loops and your program to just crash, is to use like a breadth first search across from the starting states, and you just kind of keep executing and generating. You know, you keep track of, I would call them partial completions, and each time, each iteration, you just gather more possibilities, more partials, and partial kind of completions, and every time you end up in a accepting state, you take that partial and dump that into your sequence, and you do this all lazily. And I was trying to do it with using concatenation, and I got kind of stuck, so I don't really have the final solution for you. But that's going to be the basic algorithm. It should be straightforward. Hopefully not too bad. Definitely another one of these kind of lengthy in terms of the code solutions, though. And I thought I was going to go over. Oh yeah, I'm not even going to bother to go over the other one, the alignments, the Latin squares question. That's not a bad idea to look at it, but it's definitely. I'll probably just be sad when I look and see how other people did it more efficiently, more effectively. I could look at it later. Probably not tonight because we're kind of out of time here. But yeah, tomorrow we can come back and take a look at how this is sort of the one of the best solutions, what it would look like for this one. And then we could also look at what are the best solutions for that Latin squares question. And then we're kind of almost done here. I mean, this is one hard question, and we really only have one hard one left. And these other ones I probably can finish tomorrow, I think, all in one shot. Actually, I might just be done with all these. I think tomorrow I won't even probably code on stream. I'll probably just explain the solutions and go through the code and show you the better solutions. I'll likely be done with all this. What is it? It'll be Wednesday we're done. Yeah, I predicted I'll be done with all this probably by Saturday. So we're a few days ahead. It's not bad. Assuming that I can finish these problems in one shot. I think I can, probably. Well, more likely than not, I think so. And yeah, after that, the plan was to go get a Clojure job. But I'm kind of like, I don't know, man. I'm super conflicted. I think I mentioned that. Like, I don't know. I don't know what to do. I don't know. I was actually talking to my manager about that because I told him about working remotely, and he spoke with his manager. His manager said more or less there aren't any remote positions available at the company right now, which I kind of question. I'm gonna approach one of the teams about that. Because I know there's one position that is open. I was talking to some of the guys on the team, and they seemed sort of amenable to the idea of me moving to their team. But the subject of working remotely on that team didn't come up at all, and I was gonna bring that up, sort of start the conversation with, like, in the context of I'm looking to work remotely. The alternative then would be to actually find a job in another company, which I have there's some possibilities out there. There's a lot of remote jobs out there, but the problem is like, just because the job exists doesn't necessarily mean that you're going to get that job. You know, you got to apply, you got to go through interviews, you got to actually want that job. It's got to be like, and then not to mention you might want to leave after 6 months, you know, because for whatever reason you decide it's not really worth it, your time or something. So there's a lot of like, it's not that simple. You know, I can't just like up and leave and get a remote job. But the more I think about it, the more it's like, man, I really don't like the commute. The commute is just killing me. It's kind of a lot of hours to begin with. Like I'm already there, sort of an extra hour, and then just because it's a longer shift, and then the commute on top of it is a pain in the neck. It's actually dangerous. And I've been listening to the Bible, but like, you know, probably about a year. It wouldn't even take a year, and then I'll have heard the whole Bible, and it's like, all right. I mean, I appreciate listening to the Bible 2 hours a day, but I don't know if I want to do that for the rest of my life. You know, I mean, I actually wouldn't even mind reading the Bible 2 hours a day if it was like not driving, because like you're kind of half listening when you're driving. So I don't know. I very conflicted about where I'm at in the world here. Let's see. Yeah, and if I don't want to work remotely, I mean, I could always go reapply to Google. You know, I keep bringing that up, keep mentioning that, because it's. I mean, I'm, you know, about as qualified as they get when it comes to developers. About as capable as they get. That's something to consider. And then, you know, a coworker mentioned to me, I could tutor math for, you know, anywhere from $50 to $100 an hour is what they're charging now, which is crazy. But I TA'd a computational geometry course with one of the sort of the top mathematicians of our time. So like, you know, as one of my coworkers put it, I'm eminently qualified to tutor maths. So that's an option too. I mean, you could do that remotely as well. Wouldn't mind making $100 an hour remotely. This doesn't sound bad at all. And then I don't know, man. I'm like, I'm conflicted. There's too many options, too many things to think about. Because it's about the money, but it's not even about the money, because like I kind of don't care that much. Like I do and I don't. I'm like really like it's not like a lot of money. It's just more. I don't know how to express it. It's kind of just like I'm not gonna be making all these decisions. I'm not gonna be a millionaire. I'm just gonna be like, I think, or doing those things alone. I think I should refocus on like, okay, you want to start a family. Like, how can you make that happen without like, you know, I don't know, doing things that are unrealistic or untenable. You know, that's kind of like I really got to think about this. This is like very difficult spot to be in. It's fair. I'm very conflicted, but it's pretty negative to hear that there wouldn't be remote spots in the. But that's the other thing. It's like, oh, it may not be necessary to work remotely either. I really would want to though. Ultimately, I think, because the commute's gonna suck. Like, it's one of those things. It's only gonna get worse over time. Like, I'm just gonna be more annoyed over time as the years progress, and more annoyed with myself for not doing something about it sooner. Because if I do something about it now, you know, in theory that'll be set for the rest of my life. I won't have to deal with this commute. So it's kind of worth the investment up front, worth you know, switching companies or switching jobs or whatever, because it's just so taxing. It's funny too. Like my manager, all the people in the office, they put up with that commute, and it's like, it's no sympathy. You're not getting any sympathy from these people. That's not gonna happen. Mm-mm. Which I thought was the thing is kind of weird because it's like, they could work anywhere, and I mean I don't know how much they're making, but these like big tech companies are paying like on average $200,000 a year to kind of like not entry level, but sort of basically no experience. They'll pay you about $200,000 a year. Effectively no experience, and some of these guys have been programming for decades, and it's like I don't really understand completely. I mean, I don't know if it's company loyalty or who knows what reason. But it is strange because it's like I said, like it's like you're not going to get any sympathy from these folks, but like they don't have to put up with this stuff either, I guess. So I don't know. I really don't know what to think. I don't dislike it there though, but it's just very like the commute sucks. The commute sucks. I've mentioned it before. There's sort of a lot of things about the job I really like, but a lot of things that are kind of irritating at the same time. I mean, job's a job, right? I mean, you can't expect everything to be rainbows and sunshine all day every day. But it's definitely some things that are not great. Some things that are not great. The commute being probably the top thing. Commute is like, it's funny though. It's my commute is 2 hours every day, right? Round trip 2 hours. And I come home and watch YouTube videos for an hour. It's like, did it really matter that much if you were going to waste that hour anyway? It's kind of like, Although I would argue I don't really waste my time when I watch YouTube. I usually look for something that's kind of edifying. I watch preachers preaching, or I watch, what's going on in the world, the news, or I'll find something that's really funny, I suppose, kind of lighten my mood. Which, I don't know, I guess maybe that is wasting time. I don't know, does that count? Maybe, yes, no, maybe. Certainly not working, but I don't know. The other thing to consider too, and I have considered this, is that like, one, having a miserable commute is pretty motivating. Like I've been like kind of keen on making sure I'm productive in the time that I'm not at work. And then the other thing is, it's also being at the office is I'm more productive as a person as well. Like I'm not so sure I would be as productive and like disciplined, something like that, if I was home, because I know myself and I'm way more tempted to slack off if I'm home than at the office. It's like, oh man, you spent 2 hours each day just getting there. Like you better make the most of it. Kind of a thing, something like that too. So there's kind of like pros and cons here to consider. And not to mention, it's pretty easy commute as far as like, it's stop and go traffic on the highway, but it's like literally just one road most of the way there and most of the way back. It is a little bit dangerous though, like I said, because it's a highway and people are people. They make mistakes. And there's accidents constantly. I mean, I see cops pulling people over constantly on the road. Anyway, let me not spend too much time complaining about my commute. But today was an interesting day at work, definitely, because we're talking about basically like my yearly report here, and end of the year report, and it's like he was like, right, well, if you're not even going to be here, like there's no point to doing this. So I thought it was interesting because it's actually very honest, like because the place is like a revolving door in terms of the people. I was looking at there was a printout of like old IDs and stuff that were being decommissioned, more or less. They wanted to remove them from a database, and they basically sent out like a list of names, and they were like, pretty much, if you're on this list, like, your thing's going to be removed. So if you know someone on this list who's not supposed to be on this list, just let us know, because we're going to remove them from the database. And someone was like, well, I definitely think Homer Simpson should be removed. Because someone before they left changed their name to Homer Simpson. Yeah. Oh, the point of that, though, is that they had this list, and there was 10,000 numbers, something like that. Like one of the numbers I saw was like 10, employee number 10,900 or whatever, which leads me to believe that there were probably 10,000 plus employees at this company. Well, you do the math. I mean, the company's only been around for 20 years, and the company maybe has 500 employees. So total, and that's at its probably largest is 500 or so. So what's 10,000 into, let's see, hold on. We got 10,000 into 500, or even just 10,000 into 20 years. Oops, did that wrong. Yeah, it's like the whole company recycles once a year on average. That's kind of what we're looking at here, which is actually kind of nuts if you think about it. And yeah, it definitely comes out in the code, I've noticed. There's just tons and tons and tons of stuff. It's like kind of put together. It isn't really. It gives you that kind of sense of like disconnectedness. It's almost as if you took the code. Like you could, in theory, say like take the code base, break it up into 20 pieces, and each one of those 20 pieces will be coherent with respect to itself, but will not be coherent with respect to any of the other sets, right? We were just talking about this being sets being pairwise disjoint. So yeah, these sort of the coherence of the code base would be sort of having some expectations placed on them, doing it for about a year and then leaving, and then someone else has got to pick up where they left off. But it's never quite the same because it was where someone else was. Like it's not, they don't really have the whole context of what that person was doing and working on, and so they just kind of piece together what they can, and then the next cycle comes again, and every single piece of the company was like that. On average, one year is what the person would work on it. And I even had one of the employees mention to me like, "Oh yeah, work here for a year and a half and then go move on." And I kind of like was like, "What? What do you mean? Like, wait, what are we doing here? What?" But I guess, yeah, I guess that is the standard, the normal thing to do, is not stay there for a very long time. Apparently, the average is about a year, right? After our quick maths here, even less than that, I think, because it's the employee ID was like 10,989, so it's probably even more than 11,000 employees over a 20-year period. Which is kind of a lot of people, man. That's a lot of people. Something to think about. But yeah, it's super secure job though. That's the other thing I like. It's like it's definitely like I don't see the company going under anytime soon. Because the product that they build is like very kind of difficult to get. It's like it's got some properties to it that has a lot of staying power. I don't know. I don't know what to do. I would like to stay where I'm at least for a while longer, though. But yeah, it's pretty funny. It's like, should we even do this? I did think it was a little bit kind of what do they call that? Like foreshadowing or foreboding or something, because it was like, well, technically I'm supposed to get an end of the year bonus. Like, it's like, well, what am I gonna say? I'd like to forfeit my bonus because I would like to look at other opportunities. It seems kind of unfair because I might not take any of those jobs and stay here another 2 years and just not get a bonus this year. It's like, jeez. But yeah, no. But I think also though the thing that's funny about it is like, having mentioned that there are companies that'll pay you $200,000 a year just right off the bat, it's like, and knowing what I get paid, it's like, it's kind of not even. He probably wasn't even thinking that. Like I wouldn't be upset to miss the bonus because it's like the first paycheck I get would be like like way exceeding whatever bonus I'll probably get, something like that, which is pretty funny. But I don't know. Let's not get into all that. Get too far down that road. We'll just stay the course, and I don't know. Keep mulling it over, man. Give it some time. You could have patience, right? There's no need to rush into anything here. And yeah, a lot of opportunities out there. Apparently, I have an opportunity to make a boatload of money tutoring, which maybe I should pursue that, only because it's a lot of money and it's remote. Could be remote, and yeah, and there's like loads of stuff to do. I mean, there's just a ton of things. I have a bunch of things on the plate. But I don't know, like I said, I'm kind of conflicted about all of this because it's like, I really should be focusing on having a family. Like, whatever gets me closest to that is what I should be focusing on. Which I don't necessarily even know what gets me closer to that. It's like, ironically, a stable job is very good for that, which is what I've got right now already. It's like, wait, what? Wait a minute. Wait a minute. Yeah, that's what I'm saying. It's like, I can't fit the pieces of this puzzle together. It's not working. It's too many variables. Too many things to think about. Look, if I only had $100 million, this would be very easy. Could just invest it and not worry about anything. Retire early. Oh yes, that's the right thing to think about here. All right, I'm gonna get going. So, thank you for watching. Talk to you soon. We're gonna take a look at language of the DFA tomorrow. We'll probably look at all this tomorrow. I think we should be pretty much good to go, and we could even look at the code wrangling done for the that Latin squares alignment question. That may not be a bad idea. So yeah, thank you for watching. Talk to you all soon. Have a good rest of your day.